Hello, everyone, and welcome to another industry webinar brought to you by EE Tech Media and allaboutcircuits.com. My name is Jason Montgomery, and I'll be the moderator for this session. Today, we're joined by Omron, and our topic will be on Omron's AC and DC relays for energy applications. Let me tell you a bit about our presenter before we get started. Today's presenter is Omron's Erica Martin, with a BSEE and an MBA. Her experience in the components industry ranges from manufacturing to quality, sales, and product management, and she's currently Omron's Business Development Manager for energy applications, serving as America's main contact for Omron's diverse energy product offerings. And I've got a few pieces of housekeeping before we get started. You'll see a space on your screen for you to submit questions throughout the presentation, and Omron will have the right person get back to you personally following this presentation. There will also be a few polls that are popping up throughout the webinar today, so please make sure to take the time to answer those questions as they're coming up. Your input is incredibly valuable. We appreciate you taking the time to join us today, and with that, I will hand it off to Erica.
Thank you, Jason, for the introduction. And thank you for attending this webinar today. I'm excited to share with everyone our AC and DC relays for energy applications. Again, my name is Erica Martin. I'm Omron's Energy Business Development Manager. And my role at Omron is not only promote our existing products, but also to come up with new products. So if any of you need a specific product, specific module, I will be very excited to talk about it. So please reach out to me. Before we get into the presentation, I would like to talk a little bit more about Omron for those of you who might not be familiar with our company. Omron is one of the leading innovators in product development in various industries. It's a Japanese company, $7 billion Japanese company that is segmented in several divisions such as healthcare. Healthcare is 17% of our business. I think you know us from our blood pressure monitors. They are very common in the retail stores. Then we have Omron Social Systems. If you ever been to Japan, they make those ticketing booth machines, and they are really everywhere in the world. Then we have our industrial automation business. It's 52% of our company, and that they make robots, PLCs, timers, counters. And then we have my division, which is the electronic and mechanical components division. And we manufacture relays, switches, connectors, and sensors, and also some modules. All right. So one of Omron's goals is to contribute to a better society, right? And we want to make components that help green energy. But we understand that we have some challenges with that, which is minimize the installation and maintenance costs, right? And Omron wants to help with that by developing relays that can be a low heat version that can minimize installation and maintenance costs. We also want to improve reliability and safety. And for that, we have our DC relays. And we want to improve workability and productivity. And we have some connectors for that I would like to show you as well today as well. And also we want to maximize the power availability, which is really monitor the condition, right, of the system. And for that, we have some sensors. So before we get into that, I would like to ask you, I'll bring in a poll question. What brings you to this webinar section? I'll give you some time to answer that. That really helps us to also come up with the more content for everyone. All right, thank you very much for your participation. All right, so let's start. So here is an example of an inverter, okay, which is one of the target applications for our G9K relay. So the relays are used here on the AC disconnection. So to develop this relay, customers came up to us and said, as much as we want to increase power in our inverters, is being very difficult because of the thermal management. So we said, okay, we could help you with that. If a thermal management is really a problem, we see that that's an opportunity. Let's develop a product for that. And as the inverters get higher and higher power now, we really thought it would be great to develop a product that could target specifically this condition. And that's how the G9KA was born. We developed this relay with really, really low contact resistance, 0.2 milliohms. And that's what makes it a great solution for thermal management. Also, we made it PCB instead of the standard mounting, right? That would be a contactor type. And we also made an efficient plunger that would help with the power consumption. We also have here a terminal structure specific to help with heat dissipation. So with that, we were able to develop this relay that was able to achieve what the customer needed. So we are offering low contact resistance and low coil power consumption. And our value proposition then is to replace contactors. And with that, we see that we were able to reduce man hours and work mistakes by having less wiring at the production. And I didn't know that, but when we discussed that with customers, they said it's a big problem because of the wiring, the high amount of wiring that they have with the contactors. So with that, by using a PCB relay, we can help with that. Also, it has a lower height and a lighter product design. And also, we reduce the switching device cost because the cost of a relay versus a contactor, and then while keeping the comparable switching spec. So this is a comparison of a relay versus a contactor. So we have here 3 Form A contactor and 3 1-Form A relays. With the G9KA, we are able to decrease height in 64%, volume in 32%, and weight in 76%. So it's a great reduction overall. And here we have the dimensions. So while the mounting area is about the same, you can see on height, the height of the relay is about 1/3 of the height of the contactor. And that contributes to a more compact design for your housing. So it's a big design advantage as well. Okay, so before we get into the specifications of the G9KA, I have another poll question for you. I want to know what kind of equipment your company manufactures. And I'll give you a minute to answer that, okay? Great, thank you so much, thank you. All right, so let's dive a little deeper into the specifications of the G9KA. So the G9KA is a 200 amp, 800 VAC relay. Coil voltages are 12 and 24 volts. The coil power consumption, as I mentioned, is very low. So we have a mechanism of holding voltage that can help with that. So for example, you can put the DC 12 for 100 milliseconds. And after that, you can reduce to 50% of this voltage to 6 volts. And then the coil power consumption will be 1.25 watts, which for 200 amps, 800 volts relay is a great thing. Another important feature to talk about on the G9KA is the contact resistance. Like I said, it's really, really low, 0.2 milliohms. And it keeps it low until end of life, to 0.3 milliohms. And contact gap is big, it's a 4 millimeter contact gap. And the ratings are 800 volts, 200 amps, 10 operations. And that's more than enough for the inverter, since they are going to switch that only in extreme conditions, emergency conditions. And our 30,000 operations at make 50 amps, carry 200 amps, and break 50 amps at 800 volts. And the size is very small, 51 by 51 by 47.2. You can see here in my hand, it's very small. 200 amps, 800 VAC relay is very, very small. See? And it's PCB relay. So definitely we have customers that are very happy with that. And I think it's a great choice. If you need a sample, let me know. Let me show you a little bit of our thermal performance now. So you can see here the contact resistance of the Omron relay. That's what's measured at 0.18 milliohms versus a non-Omron relay at 0.40. So I was talking until now that we compared relay versus contactor. Now there are some other relays in the market too, and that's where we compared with. But even then, when you compare, it's very different on the contact resistance. And that there's a huge difference in temperature. So you can see here that the Omron relay, the temperature on the fixed contact at 200 amps is 141.9 Celsius versus the competitor, 172.3 Celsius. So we have here a difference of minus 30.4 Celsius on the fixed contact, and on the fixed terminal, minus 27.1. Okay, so with that, you can see it's a huge difference. And when we compare also with the competitor relay plus heat reduction system of cooling fan and heat sinks, even then Omron relay has a superior performance. It has, for example, 141.9 Celsius here on the fixed contact versus the competitor with heat reduction system, 161.1 Celsius. So then if you see here the difference for both on the fixed contact and fixed terminal, and over 30C advantage. So with that, I can see from experience that we have enabled the customer to completely eliminate the cooling fan and the heat sink. So when you compare the G9KA versus a contactor, not only the relay form is more affordable, but also using this relay, you can possibly eliminate the cooling fan or use smaller fans, and you can also use smaller heat sinks. So it's something very good to consider also for cost reduction. And here's a graph of our contact resistance. You can see the contact resistance remains stable to end of life. So you have this temperature performance to end of life, and you keep the heat down until end of life. And here's our AC high power relay product lineup. So for this lineup, we have here the G9KA that we talked about. And we have other relays too that I'm going to talk about today. But I want you to see that we have a good relay lineup for energy products, and we are also expanding. So you will see here something very soon, something in this area. So if you have opportunities for that, please let me know. Let's discuss. Okay. And this is just our AC hyper relay lineup for energy. Okay. We also have many other relays for other markets. So you can check it out in our website. And here we have the latching relays as well, the 98TB. I'm not going to talk too much about them today, but those relays were developed for smart meters, 98TB. Okay. And the G6QE is also a new product that we did launched recently for residential PV inverters. All right, so let's talk about the G70B. Before that, actually, I want to bring up a new poll question, please. What are the challenges that you face with your current switching solution? I want to know that before we get into the G70B. Please let me know. What are the challenges? I'll give you guys a minute to reply to that. Great. Thank you so much. Thank you. All right, so let's dive a little deeper in the G70B. So the G70B is a relay that, just like the G9KA, has great temperature performance. So we have in this relay is 100 amps at 800 VAC. So it has the option of 12 or 24 volts coil voltage. The coil power consumption is also very low because we have that holding voltage system that I mentioned. So you can use 45% of the coil voltage, and that will drop the coil power consumption to 575 milliwatts, okay? And then you have the rated load. We have here 800 volts, make 40, carry 100, break 40, 30,000 operations. But if you do 100 amps, 800 volts is 200 operations, okay? So also more than enough for inverter applications. And at 480 VAC, 300 operations, okay? And contact resistance, we put here 5 milliohms initial, but contact resistance measure typical is much lower than that. And we guarantee to end of life lower than 10 milliohms, which is also very good for this kind of relay. And dimensions is only 50 by 37 by 40. Let me show you our G70B. This is our G70B. It's a very small relay. If you see, it's 100 amps, 800 VAC, right? Very good. And it's also PCB mounted, okay? And the applications are inverters, UPS, or industry inverters. And like I mentioned about the G70B's contact resistance, the measured contact resistance is 0.5 to 0.7. So you see the same thermal performance as the G9KA that I mentioned before. So it's the same advantages of low heat, okay? And we have two types of PCB terminal. We have the Omron type, and we also made a competitor compatible type, so customers have more flexibility. Okay. And like I mentioned, G70B also keeps it low contact resistance to end of life. You can see here the sample haven't even arrived to 2.8. So it's very stable. Now, to improve reliability and safety, I would like to talk about our DC relays. But before I get into that, I want to also ask you another question. What are the future trends for relays in your application? What are the future trends? I want to know. Please share with me. And I will give you guys a few minutes, seconds to reply that. Thank you. Great, thank you so much. Thank you. All right, for the DC relays, I want to share with you two new relays that are coming, two new relays that we have actually. One is coming, the other one's already launched. So here's an example of energy storage system, okay? So these are the relays that I'm talking about here. And we almost saw that there was a trend for switching higher voltage, higher current. And that's why we developed these relays. So we have here the new 50 amp 600 volts DC relay for the main circuit shutdown. And we also have the 500 volts 10 amp relay. It's called G2RGX for the inrush bypass. Okay, and both of them are compact size and also have low coil power consumption. But how can Omron make DC relays so much smaller? So yes, you can imagine, I could never imagine 500 volts in such a small relay. And the way that Omron does that is through magnets. If you see what's in the market today, some relays use gas to extinguish the arc. And those relays are normally bigger and bulkier and very expensive. And Omron uses magnets to extinguish the arc. So, you know, it's much harder to extinguish DC than AC. So Omron uses a magnet to stretch the arc. And that's how we are able to make so much smaller part than compared to the gas-filled relays. We also have a good arc simulation technology that helps a lot with that too when we are in the development process. We can see exactly how the arc is going to behave, and that's how we are able to develop the product faster. And here's our lineup for DC relays. As you can see, this is very big, and that's only for energy. So we even have other models as well. So I'm going to talk about our new 50 amp relay, and you saw here, you saw me holding the G2X. But yeah, we have a lot of relays coming up and a lot of relays already in this range. But first, I want to talk about the G9KB relay. It's our upcoming relay. It's going to be a 50 amp, 600 volts DC relay. And it's going to, the coil is going to be 12 and 24 volts. The coil power consumption, 0.57 watts at 45%. It's going to have a big gap of 3.6 millimeters. It's also going to have a low contact resistance, which is lower than 5 milliohms. And it can switch 50 amp, 600 volts, 2,000 operations. Okay, and of course you have higher number of operations also for the other ratings that we have. And most importantly, I want to talk to you about the polarity. So no polarity, so it means that it's a bidirectional relay. So when you have, for example, applications such as energy storage, EV chargers, it's interesting to have a bidirectional relay. So we see other relays in the market, but they are not bidirectional. And that means that you're going to have to use another relay here to charge and discharge. In this case, because the relay is bidirectional, you can charge and discharge through the same relay. So that eliminates a whole other component of your solution. So it makes it more effective. Okay. And it's also PCB mount. The size is very small too, 50.5 per 37 per 50.5. It's going to be very small. That relay is coming up soon, so if you need samples now, let me know. Another product, DC relay that I want to share with you is the G5PZX. So with two pieces connected in series, it can switch 400 volts, 20 amps, and those are also bidirectional. Okay. You can see here the power consumption is 530 milliwatts. And the rated load for the two relays is 20 amps, 400 volts DC. Or if you want to use just one relay, is 20 amps, 200 volts DC. Okay. Here's a sample of the G5PZX. You can see it's very small. Okay, great. And this is the G2RGX that I mentioned previously. It is also the target application is the pre-charge for the residential energy storage or EV charger. The coil is 12 or 24 volts. The power consumption is 0.8 watts. And the contact rating is 10 amps, 500 volts DC, okay? And that's 10,000 operations, or if it's 1 amp, 500 volts DC, 30,000 operations. And like I said, it's very small, PCB form. See? Great. Now I want to introduce the G7LX. So the G7LX is capable of switching 1,000 volts low. Yes, it's a great relay. You can see the size of the relay, and it can interrupt 1,000 volts DC. So this relay was developed back in 2014 for the changes on NEC 690.12, and this relay was developed to switch to shut down the whole array, this whole solar array. So it has the ratings for 600 volts, 30 amps, or 1,000 volts, 25 amps. So just this relay could switch the whole array, either a residential or commercial array. And actually 2 arrays, because if you use them in parallel, you can actually switch two arrays. And this relay is also bidirectional, as you can see here. So if you want to use them for the battery as well, it can be a good option. Okay, but yeah, it is very used, this relay, in rapid shutdown systems now, and either 2017, 2020, or 2014, where you switch the whole array, this relay can do both. And power consumption is also very little, at 0.6 watts at 50% holding voltage. Okay. And also we have other solutions for low voltage applications. The same relays that I showed you before, the G9A and the G7B, they have DC rating as well. So the G7B DC rating is going to be 60 volts. And then here you have the number of operations per current, different levels of current. And here on the G9KA, 200 amps, 60 volts. This number of operations is still to be defined, we will confirm, but the rating is also coming soon. And on the G7B, the DC rating is already there on the datasheet. Now, I also want to show our DC relays that are 400 volts line. These DC relays are our automotive DC relays. So you can see we have, they are 400 volts. They go from 60 to 300 amps. And the differential of these relays is that they are also suitable for being used inside the car. So if you are a car manufacturer, you can also use these relays inside the car. Okay? And they are manufactured in our automotive factory, so we can support any PPAP documentations you might need. Another relay, DC relay that's automotive, is this one. Here's the G9EJ, and it's a 15 amp, 400 volt relay. It's very small, 27 by 31 by 32. But I also wanted to show this to you today because it can be used inside the vehicle. Now, to improve reliability and safety still, we want to introduce our connectors. And our connectors, they have a push-in terminal block. Let me show you. This is an example of a PV inverter, okay, a control board. So we have the power board to control board, and we also have connections to optionals that are on the equipment, right? And the same feedback that we had from our customers that abnormal wiring cause also a big concern of heat generation, right? So for that, we have 2 solutions. That is our push-in type wiring connector, and also our XG4 connector. Both are board to board. And here's our X4MN connector. Okay, so this, like I mentioned, is just a push-in type. So you just insert the wire, and once you insert the wire, it locks the wire there. And that's great for optional equipment that you just attach, or you have to perhaps attach in field. So very easy to assemble just by pushing in. And it has a very low insertion and extraction force. And that increases a lot productivity actually on the production line. Once it's locked, it's very strong. The locking is actually very strong. But what I mean by insertion and extraction is that just when you are mounting, it's very low insertion. And you can see here the difference. Insertion force level is down by 85%, and extraction force level is down by 79%. And Omron's very good at this. You can see that from our FPC connectors as well. That's one of our strengths of our connectors. And we see that once we start using that, the actual production engineers start promoting Omron because they see the difference it makes on the operators, easy to work. So they end up promoting even these connectors for us. And this is our XG4 connector. Now, I know you have seen this connector before, but what I want to bring to your attention is the dimensions of the tab here, of the lock. So you see that Omron is 8.2 versus competition is about 3.65. And what it does is that it's much more comfortable for the operator to use this type of lock, much more comfortable on their fingers. And that not only increases productivity, but also decreases the unreliable mounting that you might have due to operators' fatigue. So I think that's a very big point for Omron's connectors. And now to maximize the power availability, we have our condition monitoring sensors. So for example, here is our thermal IR sensor. This is a sensor that we use to measure temperature or hot spots in the equipment. So we have several applications for that in the energy field. And currently, some customers use thermal camera, which is very expensive, and thermal label that it cannot monitor continuously. So our solution is to have this thermal IR the thermal IR sensor that can give you a continuous reading of the temperature. Okay, so then you can take countermeasurements in case you see that the temperature is increasing. And actually, we have many sensors. So we have, for example, our human sensing OCAL software, and that software can recognize a face and expression, age estimation, gender, face direction, body detection, hand detection. And I see that for energy applications as well, because we see some EV charger manufacturers using their chargers in public places to do advertising. And in this case, by using our OCAL software, they could perhaps even do targeted advertising. Then you have the MEMS thermal sensor that I just showed you. But also we have lots of other sensors. For example, the flow sensor, our D6FV, is used a lot in energy to detect clogged filter. So you have applications like energy storage, and the filter is clogged, the air vent is clogged. So our sensor can tell you that. We also have seismic sensor. This is an earthquake sensor, actually. It's not just accelerometers. We have an algorithm to detect earthquake itself. As our products are developed in Japan, and Japan, unfortunately, has to deal with a lot of earthquakes, Omron has done a lot of extensive study on the data to come up with the algorithm. So that's one great advantage that we have. And once you detect the earthquake, then you can shut down, for example, your inverter, you can shut down your utility and everything. So I think that's a great sensor for the energy market. Then we also have our photo microsensors, and these are used a lot for like open, closed door detection and tempering. So it's a good way to detect that. We have our environment sensor too. Here you can see 3 types of environment sensor. We have the portable one, the USB one, and the PCB one that can be embedded in your PCB. And those measure temperature, humidity, pressure, light, noise, and UVI. And those also have a seismic sensor on it. So you can also have all in one. And I see that used in energy too for on the energy panels. And also we have here our B5Ws. We call light convergence sensor, and we are coming up with a new utilization for that on the energy industry for transformer oil quality monitoring. So I'll probably do a separate webinar on that, but I think it's very good to mention right now. This is an upcoming solution. Okay. So that's it for me, guys. I want to ask one more question for you guys after today's presentation. Do you think it's a good fit for your application? The Omron products are a good fit for your application. Please let us know there. And while you answer, I would like to invite you to subscribe to our newsletter, our Component Insider newsletter. Because on this Component Insider is going to be where you're going to be informed of new products, okay? The new product launching. And again, my name is Erica Martin. You can reach me at erica.martin@omron.com. And please visit our website to see our new solutions, components.omron.com. Thank you.
Thank you very much, Erica. Everyone, this is Jason Montgomery back here again. I want to thank everyone for taking the time to join us for this webinar session. I know that we had a good number of questions come in, and you'll be getting contacted directly for the appropriate answers that you are looking for. One thing that I'll point out to everyone who's still here with us, you'll see a handouts tab that's on your screen, and on that you'll find a PDF brochure that we think will be useful for you to look over as well. When you are exiting the webinar session today, you'll be redirected automatically to Omron's industry webinar landing page on allaboutscircuits.com. So please make sure to check out any past webinars that they've done with lots of other really valuable resources for everyone in attendance here as well. Again, thank you to Erica and Omron for joining us, and thank you so much to all of our audience members for taking time to attend this webinar. We look forward to seeing you at another webinar session again sometime soon.